Identify the length in inches of the highlighted arc. So this is what we're looking for right here if you want to draw this picture. We're given that the radius is 7 of this sector. The radius is 7 inches. We're not told the exact central angle. What we're told is that everything but the central angle is equivalent to 6 pi over 9. Now, if we made one complete revolution, it would be 2 pi. We want to extract this portion to leave us only the central angle. So we're going to subtract 16 pi over 9. What is the shortcut to doing this? Grab your calculator, please. We're going to exclude putting the pi into the calculator. And we're going to type in 2, subtract, and then in parentheses, 16 divided by 9. Put it back into a fraction. We end up with 2/9. 2 pi over 9. Now, could we have done that by hand? Absolutely. So I put a 1 at the bottom of the 2. I make a common denominator, which is 9. So multiply times 9, multiply times 9. 18 minus 16, 18 pi minus 16 pi is 2 pi over the common denominator of 9. So I'm going to circle this and I'm going to draw an arrow to the central angle. Last Friday we learned that to find the arc length, and that's the goal for this problem, arc length represented by S is equal to radius times central angle. Remember, your central angle always has to be in terms of radians. So I can take 7 times 2 pi over 9. Since it doesn't tell us to round to a tenth or to a hundredth, I'm going to leave it in terms of radians. What does that look like? 14 pi over 9. Problem solved. Does anybody have questions for me about this problem? Please make sure you're taking good notes. Number 2, 3, and 4 are similar in only a little bit, similar to something you learned in geometry. So it's going to say name the 5 other trigonometric functions. So we're going to come off to the side here. We're going to leave this entire area here to show work. We're going to need that area. Come off to the side and let's write them down. We have the sine of an angle, cosine of an angle, tangent of an angle. Now we're going to take the reciprocals, which we learned during this unit. So sine. The reciprocal of sine is cosine. Reciprocal of cosine is secant. Reciprocal of tangent is cotangent. All right? So I'm going to do this problem fairly slow. Here's the parameters. You know your central angle is between pi and 3 pi over 2. So I'm going to start by making what you would relate back to an XY graph. Remember, now we think of it in terms of the cosine and the sine. And if we had a circle here and you had to identify where pi is, pi would be right here, and 3 pi over 2 would be down here. So the parameters say that this central angle lies somewhere in this section. What quadrant is that? Quadrant 3. Okay. So here's how you start this type of problem. You first identify the parameters. Then I want you to draw a dot somewhere between these two. It makes no difference to me where you draw it. I tend to draw it somewhere in the middle. And you always go directly back to the origin. And always draw a line that will go directly to the x-axis, creating a right triangle. Your central angle is going to be the angle that's created with our new line and the x-axis every single time. Now I like to take this triangle and I like to make it just a little bit larger for us to work with. And to ensure I don't make any small mistakes, in quadrant 3, what are the sine values? Right, sines are negative, cosines are negative. Remember, tangent means sine divided by cosine. So if you take a negative value divided by negative value, you always end up with a positive value. The reciprocals of cosine, cosecant, secant, and cotangent will have the exact same signs as the ones that they are similar to. So this will be negative, negative, and positive. Okay, so why is this negative? The reason it's negative is because in quadrant 3 we know the cosines are negative. So for this time, cross this out so it doesn't confuse you. Cosine, remember, when we think SOHCAHTOA, when you think of the cosine, you're thinking of adjacent over hypotenuse. From this angle, there are 3 sides. Which one would you classify as the adjacent side? Most students know it's one of these two. Remember, this is always opposite. It's opposite of the angle. This is your hypotenuse, leaving this to be your adjacent side. So, cosine of this angle means that 4 will be the adjacent side because cosine is adjacent over hypotenuse. Your bottom number is 11. It is the hypotenuse. It's very important you take good notes today to be able to do any of your work. All right, now how do we come up with this third side? Because we have a right triangle, we could do a squared plus b squared equals c squared. These represents the 2 legs of your right triangle. This is your hypotenuse. It doesn't matter if you assign 4 to a or to b. It makes no difference. So 4 squared plus b squared equals 11 squared. I know this is 121, and I'm going to subtract the 16. Can you please do that on the calculator for me? 121 subtract 16 gives you a value of 105. All right, now when you solve an equation, this tells us you're going to have 2 answers. So this will be b equals plus or minus the square root of 105. But b represents the length on a triangle, and lengths are always positive. So b is only positive 105. Grab your calculator. We're going to see, can I break down 105? What I mean by breaking down 105 is because I have a square root, are there perfect squares that divide into it? So we're going to go through this slowly. The first square root, perfect square, is 1. Well, 1's not going to reduce anything. Let's divide by 4. Nope. Divide by 9. No. Divide by 16. 25. 36. Can you raise your hand if you're understanding where I'm getting these numbers from? Only 4 or 5 of us. Okay. Because I have a perfect square, I want to see if this can be reduced. So if you're confused, I'll give you an example. If this happened to be the square root of 20, the square root of 20 can break down to square root of 4 and square root of 5. So I would rewrite it as 2 times the square root of 5. I want to know, can I rewrite this radical? Okay? So I've tried 36. Let's try 49. I can see these are not working, so it looks like it cannot be reduced. 64, I know after this point, I've already gone past 1, it's not going to be reduced. Okay, so I'm going to come over here, I'm going to write the square root of 105. Each one of these will have a fraction, so I'm going to make a line that extends out for the fractions. Let's start with the sign. So your sine, from this angle, sine is opposite over, whoops, this should have been, so it's been an OH, it's my fault, is opposite over hypotenuse. So from here, your opposite is 105, your hypotenuse is 11. We already know our cosine of the central angle is negative 4/11. The tangent is going to be opposite over adjacent. Opposite is 105, adjacent is 4. Square root of 105 over 4. Now, how do I easily come up with these? You're going to flip them. You're going to take the reciprocal. But remember, you can never leave a final answer with the radical on the bottom. So when I flip this, it becomes 11 over radical 105. Mathematically, I didn't do anything wrong, but it's not proper to leave it in this form. So I want to teach you how to do this the slow way, and then how do we get the answer the fast way. We're going to take the top and bottom by what we see in the denominator. In doing so, we get 11 radical 105, and when you multiply the square root of the same number, you end up with just that number on the bottom. So this is negative 11 square roots of 105 over 105. As a reminder, if you're asking yourself why is it negative, these two will have the exact same sign. Likewise in the next two, okay? When I flip this one, it's easy. There's no radical involved, so it's negative 11 over 4. Notice that this situation is the exact same as this situation. When I flip it, it becomes 4 on top, 105 on the bottom. So I'm going to multiply the top and bottom by the square root of 105, and I end up with 4 radical 105 over 105. Going on to a similar problem, example number 3. Okay, I'm going to start by making myself what we would describe as an XY graph. Remember, it's cosine and sine. And then I'm going to identify what are the parameters here. What are the parameters? And so I know that 3 pi over 2 is down here. And I know 2 pi is up here. So somewhere in this region is where I'm going to have a central angle. From the origin, come straight out until you hit somewhere along this unit circle, then always go straight back to the x-axis, creating that right triangle. I'm going to redraw this right triangle, and again identify where your central angle it is. It's always the angle that's next to the origin and next to the x-axis. I'm going to go ahead and I'm going to identify the 6 trig functions. We already have one of the 6, so I have 5 remaining. So I have sine of the central angle, cosine, tangent, cosecant, secant, and cotangent. And as just a little reminder, down below here, I'm going to write so, ka, toa. Okay, so we know in this region the cosines are positive because cosines are like x's. In this region, cosines are positive. So find cosine, make both cosine and secant positive. In this region, sines are negative. Make the sine and the reciprocal of it, cosecant, negative. Now tangent is really sine divided by cosine. So sine divided by cosine, regardless of what the value is, a negative divided by a positive is a negative. These two will always have the exact same sign. Why is this value negative? The reason is because sines are negative in this quadrant. So cross out the negative right now so it doesn't confuse us when we're drawing a triangle. From this angle, sine means opposite over hypotenuse. Opposite over hypotenuse, okay? So the opposite is the number 3. Opposite is 3. Hypotenuse is 5. I'm given a leg and a hypotenuse, and I have a right triangle. A squared plus b squared equals c squared. This leg 3 can be inserted for either the a or the b. It makes no difference. 3 squared plus b squared equals 5 squared. B squared equals 25 minus 9. B squared equals 16. Again, when you solve a problem like this, this tells you should have two answers, plus or minus, in this case, plus or minus 4. But because we're working with a length here, we know lengths are always just positive, so b equals 4. You put into the missing leg a 4. Okay, let's fill in the remainder. What do we know? Okay, we know the sign is -3/5. So -3/5. Reciprocal, flip it around, is 5/3. It's nice when you don't have any radicals. The cosine. Cosine means adjacent over hypotenuse. Adjacent, that means it helps create this angle, the central angle, but it can't be the hypotenuse. That would be the number 4. So 4/5. Here's 4/5. Reciprocal, 5/4. Tangent. Tangent is opposite over adjacent. Opposite is 3, adjacent is 4. -3/4, -4/3. The next problem will be something very similar, very similar. Can you right now do me a favor, 1 through 5, not based on speed, just on the understanding, 1 through 5, where are we at? Raise your hand up high so I can see. Most of us are 3s, 4s, and 5s. Okay. All right, we're going to go down below. Let me just take a second and fold this. This is the same type of problem, just written in a different way. Okay, so this problem says evaluate the sign when you know the cosine is -√63/12 and you know it's in the second quadrant. So let's do this right now. We only have to find the sign, so circle that. We don't have to do all of the other trig functions. Let's start by making ourselves, again, what we think of as an xy axis. Within trigonometry, we are thinking cosine and sine. We know it's only going to be in the second quadrant. So the second quadrant, if you've forgotten how to label these, I think of it as a capital C. Here's quadrant 1, 2, 3, and 4. You're making a capital C. 1, 2, 3, and 4. So look to quadrant 2, and we're going to make a dot somewhere in quadrant 2 along the unit circle. Doesn't matter exactly where that dot occurs. Go straight back to the origin. Now from that dot, we always go to the x-axis, never to the y. When you go down to the x-axis, you're making a 90-degree angle. Let's rewrite or redraw that triangle. Remember, your interior angle, your central angle, is always the one next to the origin. Okay, so I'm going to write the SOHCAHTOA here. It's good practice. So, SOHCAHTOA. All right, so why is this negative? Because cosines are like x's, and in this region, I know that cosines are negative. That's the reason there's a negative up front. I can see here that this could have been reduced, and we'll do that together in a little bit. My final answer is going to be the sine of this angle. I only have to figure out one trig function. In quadrant 2, are sine values positive or negative? Positive. Okay, let's draw this triangle. So, cosine is adjacent over hypotenuse. Forget about this negative. Adjacent to this angle is down here, radical 63, and hypotenuse is up here, which is 12. Again, that radical 63 can be reduced. We can do that together in a little bit. How do you find this missing leg? A squared plus b squared equals c squared. Square root of 63 squared plus b squared equals 12 squared. When you square a square root, it cancels, and I'm left with 63 plus b squared equals 144. Please take on your calculator 144, subtract 63. And the answer is 81. B squared equals 81. When you solve this again, you're going to get a plus or minus. In this case, it's plus or minus 9. But B represents the length of a side of a triangle, and lengths are only positive values. So B equals 9. How do we find the sine? Sine is opposite over hypotenuse. Opposite is 9, hypotenuse is 12. 9 twelfths can be reduced. 9 twelfths reduces to divide by 3, divide by 3. There's your final answer.